Okay, so for this lesson we are graphing some more. The difference is we're graphing using intercepts. Do you guys remember what intercepts are?
Kind of.
You kind of heard me teaching it to the 8th graders the other day. An intercept is where your line that you're graphing crosses an axis, such as the y-axis or the x-axis. You see, oh, I need to make this mirror. Hold up. Thank you. So you see our graph here. We have the y-intercept is at 0, 6 because that's where it crosses the y-line. And our x-intercept is over here at 3, 0 because that's where it crosses the x-line. So these are your two intercepts. I mean, it's pretty self-explanatory when you hear the word intercept. It intercepts the line. So the way to graph is you're going to solve for each intercept. So let's look at example 1. We're going to find the x and y-intercept of the equation 2x plus 7y equals 28. This is currently written in standard form. Now you could graph this by solving for slope-intercept form and graphing, but this is another method. So to find the x and y-intercepts, you plug in a 0 on the variable that you're not solving for. So for instance, if I'm solving for the x-intercept, I'm going to put a 0 where the y is. So I would rewrite this as 2x plus 7 times 0 equals 28. If you think about a coordinate here, we're solving for x, so y in the coordinate is automatically 0. And we're going to solve for x. Okay? That makes sense so far?
Would you times 28 by 0?
No. This is just, I'm showing you how it's going to look once you finalize the solution. So first you have 7 times 0, which is?
0.
So that's gone. So I have 2x equals 28. Now how do I get the x by itself?
Divide.
Yep, divide by 2. So x equals what?
14.
14. So to write this as a coordinate, it'd be 14, 0, because the y we set as 0. Remember, this is x and this is y. Okay, so that's one intercept. We have the x-intercept now. So let's go solve y-intercept. We start over. We have 7x, nope, 2x. I forgot. 2x plus 7y equals 28. So we're solving for the y this time. So what am I going to put in the x place? Yep, I put a 0 where the x place value is. 2 times 0 is?
0.
So we don't need it anymore. How do I get the y by itself?
Divided by 7.
Divided by 7. 28 divided by 7 is? 4. So my y-intercept would be 0, 4, because this is the y value. All right, and then to graph it, so write our two intercepts. The first one was 14, 0, right? And the second one we solved was 0, 4. So now we get a graph. And to graph these, the x line, let's go by 2's on all of these lines because it only goes up to 10, so that's how it. So on the x line, 2, 4, 6, 8, 10, 14. And on the y line, up to 4. And then graph. And when you change the measurement, always label it. So we're going by 2's. I'll put a 2 there. All right, so we solved for each intercept, and then we graphed them. Any questions on how we did that? Do you want to do another practice on just the intercepts, not graphing it? If they tell you to graph it, you need to get the intercepts into this format. Look up here. So this is your x-intercept, this is your y-intercept. I could have written it as 14, 4 as these are the intercepts. But that doesn't help you graph it. So if you put it in this form, then you can easily graph it. That's why. But if the question of practice, you can choose whether you're going to put this in your journal. It's guided practice number 1. 3x plus 2y equals 6. All right, let's solve for the x-intercept first. Where do we plug in a 0?
A y.
Where the y is. So 3x plus 2 times 0 equals 6. 2 times 0 is?
0.
So that's gone. So I get 3x equals 6, which is?
2.
Very good. X equals 2. Now to solve for the y-intercept, I plug the 0 where?
Where the x is.
Where the x is. Very good. So then that's gone. Divide by 2. Y equals 3. So if it just wants you to solve for the x and y-intercept, you can actually come down here and write this as 2, 3 for the intercepts.
What did we do last time? What was that?
That's if you're graphing it. You need the points.
Graphing
The x-intercepts. X and y-intercepts. I'll go back. Just asking you what are the intercepts, you can write it in this form. X being the 2 x-intercept and the 3 being the y-intercept. Okay?
Yeah.
Let's do one example. This is guided practice number 3. I have negative 3x plus 5y equals negative 15. All right, solve for the x-intercept. Where am I putting my 0? Very good. Y times 0, 5 times 0 is negative 15, so that's gone. Divide by negative 3. So x equals, yep, I heard him. So if I'm solving for the y-intercept, I plug the 0 where? Where the x is. Very good. So that's gone. Divide by 5. So y equals what? Negative 3. So my x-intercept is 5. My y-intercept was negative 3. There's your answer. All right, feel like you got a handle on those? Okay, let's do another one where we graph. This is example 2. Put this in your journals. We're going to graph the equation x plus 2y equals 4 by finding the intercepts. Well, the x-intercept is easy, right? Because if I plug in a 0 where this y is, all of a sudden that's gone. I'm left with x equals what?
4.
So then let's just solve for the y-intercept, and I plug in a 0 here. So I get 2y equals 4, which is just what? Y equals
2.
Very good. So in order to graph these, I need to put them in points. So my x-intercept would be 4, 0, and my y-intercept would be 2, nope.
0.
Thank you, good job. 0, 2. Good. I'm glad you guys caught it. That's the important part. All right, so we graph these. On the x line, we go to the right how many?
4.
Yep. And on the y line, we go up 2. Yay. Any questions? All right, let's look at example 3. Says use the graph to find the intercepts. All right, so looking at this graph, can you tell me right away which is the x-intercept?
2.
Does everybody agree with him? And then what is the y-intercept?
-1.
Again, does everybody agree with him? You are correct. So you can either write it like I've written it, x int intercept equals 2, y-intercept, or I could have written it 2, comma, -1. When it's just asking you to write the intercepts, this is the better answer. It's a little more formal, which is a better answer. This is not wrong. All right, so let's look at the key concept. We've already actually gone over this, but let's make sure it's in your journals. All right, this key concept is just talking about when you're looking at intercepts, points, and graphs. I've already taught you. When you find the intercept of y, it can be written as 0, comma, and then whatever the number is. In this case, they're using the letter B for the number. And the x-intercept is written as the number, comma, 0. So we have already gone over this. It's just the notes to put in your journals. All right, so let's apply this using a real problem. This is example 4. We're event planning. You're helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. This situation can be modeled by 4x plus 6y equals 180. Where x is the number of small tables and y is the number of large tables. So we're trying to figure out how many of each size table we want to add up to 180. In order to do that, we're going to find the intercepts and graph it. So, to find the x-intercept, what's my first step?
6 times 0.
Put 6 times 0 equals 180. So that's canceled. I get 4x equals 180. Divide by 4 and you get what? 180 divided by 4? 45. So our x-intercept's 45. Let's try the y-intercept. So I plug in my 0 where the x is. So divide by 6. Y equals 30. So interpret this with me. When I'm looking at how many tables I'm going to get, the x-intercept represents me not buying or renting any of the 6-person tables, right? Because I put my 0 here. So I'm getting 0 6-person tables, and I can get 45 4-person tables. On the other side, if I get 0 4-person tables, I can rent 30 of the 6-person tables. So if I graph this, x equaled 45, y equaled 30. So let's graph this by 5s. 5, 10, 15, 20, 30, 45. All right, so when you're deciding how many tables to rent, basically anything along this line would be your combination. If I look at this point right here, I'm going to be renting 10 of these kind of tables, 5, 10, 15, 20, and 25 of these tables to make up. Does that make sense? because the point is 10, 25. So I'm going to rent 10 of the X value tables, which is the 4-person tables, and I'm only going to rent 25 of the 6-person tables. That
Why
make
is selected?
this is just showing you that if once you have your equation, which was that 4x plus 6y equals 180, anywhere along this line is going to show you, if I rent 10 of one kind, say if I rent 10 of those, then it's going to mean I only need, actually the other way around. I'm renting 25 of these kind, then I would only need 10 of those kind, because it's a point that's on this line that we graphed. Make sense? That's how you actually use this math in real world situations. Okay, that's the last example. So 4 through 15. I would probably give you Monday to also work on this. So if you just focus on getting this done today, I'll give you the IXL on Monday.